Hello everybody, welcome to this episode on statistics. In this video, we'll be going through normal distributions, the empirical rule, the z-distribution, and the z-table. So, what makes a normal distribution so special? Let's talk about all the perks and facts about a normal distribution. Firstly, a normal distribution is symmetrical. It's not always symmetrical, but it looks like it's symmetrical. And it also has one very high point. If a graph, it doesn't have to be normal distribution. Any graph, if it has one point like this, that means it's unimodal. It's called unimodal, and the normal distribution is always unimodal. And if you cut the graph exactly in the middle, that's where the mean is. The mean is always in the middle, no matter how the normal distribution looks like. If it's a normal distribution, the mean is always in the center, right here on the highest point in the center. That's where the mean is. And if the normal distribution is symmetrical, exactly symmetrical, then that's where the median is also. But that's usually not the case. It's usually not exactly symmetrical. So let's write everything in point form. The normal distribution is symmetrical, or almost, it doesn't matter. The normal distribution is unimodal, and the mean and standard deviation affect the normal distribution. Now, what do I mean by that? Let's say that this is a y-axis plane. If the mean is at 20, then the center of the graph of a normal distribution is also at 20. If the mean is at 40, the center of the graph is at 40. So the mean affects where the graph is. And what about the standard deviation? Let's say that the standard deviation of this graph right here is 1. So how will the graph look if the standard deviation is 7? This is how it will look. If you do not know what standard deviation is, we actually made a video on it. I'll put it down in the description. But standard deviation basically shows the spread, how much the data is spread around the mean. If it has a very small standard deviation, that means all the data is close to the mean. But if it has a very big standard deviation, that means all the data is spread out. But what you do notice is that, okay, before I tell you that, just notice that the normal distribution, the line never actually touches the y-axis. It's always above. But what you do notice is no matter how large the standard deviation is, there will always be some data to the left, there will be some data to the right, but most of the data will be clustered around the mean. Okay, so we've added that, we've known what that is, and the empirical rule applies to the normal distribution. So what is the empirical rule, you might ask? The empirical rule, also known as 68-95-99.7 rule. Let's say that this is a normal distribution, and this is the mean. Let's say the standard deviation of this normal distribution is 2. Then this point right here is minus 1 standard deviation, which is basically just the mean minus 2. But let's just call it minus 1 standard deviation, and that one is in front is plus 1 standard deviation. So basically just the mean plus 2 and the mean minus 2, but let's just call it minus 1 standard deviation and plus 1 standard deviation. This area right here, from minus 1 to plus 1 standard deviation, 68% of the data lie there. From minus 2 standard deviation to plus 2 standard deviation, 95% of the data lie there. And from minus 3 standard deviation to plus 3 standard deviation, 99.7% of the data lie there. There will always be some data to the left and to the right, above and below that, but this is the empirical rule and it usually applies to every single normal distribution. So this is called the empirical rule, and it's good to memorize it. Now let's come to the z distribution. The z distribution is basically a normal distribution, but with the standard deviation, also represented as the symbol sigma, is 1, and the mean is 0. Mean is represented with the symbol mu. So the standard deviation, with the standard deviation 1 and the mean 0, it's supposed to be a normal distribution, and that's the z distribution. So this is how a z distribution will look like, also known as the standard normal distribution. So this exactly is a fixed normal distribution, and it's called the z distribution. It can be, if this standard deviation is 1 higher, if the mean is not 0, then it's not a z distribution. It's just another normal distribution. But this right here is the z distribution. So, and these values right here are called z values. And you can take your normal distribution, a value from your normal distribution, and convert it into a z value. The reason why these z values are so special is what I'll show you in a second. Let's say that this is the z distribution, and let's say that this is the normal distribution that you have with the mean of 20 and the standard deviation of 2. Let's say that these are the results of a test, a student test. 20 is the average, and 26 is the best mark, 14 is the worst mark. Let's say that you got 22 marks. So if you tell somebody that you got 22 marks, they would not know if it's good or not. But using this formula, you can convert this 22 into a z value. So this x is the number we chose, which is 22, minus the mean, which is 20, divided by the standard deviation, which is 2. So doing all that, 22 minus 20 divided by 2. We know that 22, the z value of 22 is 1. So next time, if somebody asks us what our mark is, if we say it's 1 standard deviation of the z value is 1 plus 1, that means that we got 1 standard deviation better than the average. That means it's good. And exactly the other way around, it works the other way around too. If you say your z value is minus 2, that's 2 standard deviation below the mean. So that's bad. That's how you use the z value. Another way to use this, and this conversion is called standardization. Another way to use the z value is, let's think of this normal distribution and let's think of everything inside here as area. And we know that the z value of 22 is 1. We can find the so-called area of all the digits that's below 22. I'll tell you how to do that. So we do know that the z value is 1. This is called a z table. A z table is something you can find in the internet, you can find it in books, you can find it anywhere. This is what we'll need to be able to find that area. So our z value is 1. Let's put it right here, 1.00. That's basically 1. So how do we actually use this table? So first thing we have to do is take the first 2 digits here, which is 1.0, and we have to look for it in this row right here. And we found it's right here. And then we have to look at the last digit, which is 0.00. That's right here, 0.00, and we found it, which is right here. So if we intersect both of these, we find that the number is 0.8413. So what can we actually do with 0.8413? Let's bring it to this place right here. So we found out that the area of this is 0.8413. So you might be asking, area, what can I do with that area? We can find the probability of 22 occurring in this normal distribution. So if we multiply 0.8143 by 100, that'll get 81.43. That shows that 81.43% of the data lies below 22. So this blue part right here, 81.4% of the data, 43% of the data is below it. Another way to put it is, if you select a random number in this whole normal distribution, there's an 81.43% chance that it's below 22. So another question you might have is how to calculate this in front of here. So everything I just said, the same steps. Do it again, which is we get the same number. We always get the same number, 0.8413. This time you have to do 1 minus 0.8413. Just do 1 minus that number, and then it's 0.1587. So just like that, if you multiply that by 100, which is 15.87%, that shows that 15.87% of the data lie above 22. So just in case you guys have understood, I'm going to show you another example. Let's take 2.78. So let's see these first 2 digits right here, 2.7. Now we have to look for it over here, and I found it. It's right there. And then we have to look for 0.08, which is this 8 here. So just pretend that these 2.7 is 0. So 0.08. Now we have to look for here, and I found it here. And if we intersect both, we find that we get 0.9973. That's how we use the z-table. Another way to put it is by saying P is by putting it like this, which basically means P, which is the probability of Z, which is just a variable, being less than 2.78, which is the Z value, that is 0.9973. And if you multiply it by 100, it's 99.73. So there's a 99.73% chance that Z is lesser than the Z value. And that's how you use the Z table. Thank you very much, guys. If you found this video informative, consider leaving a like. If you want to see more videos like this, subscribe to the channel or check out our playlist. If you have any questions on the normal distribution or Z distribution or on anything, please put it down in the comments below. Thank you all for watching. See you all in the next one.